Hello, class. We're at the very end of chapter 9. This is the very last lesson. So congratulations for going through it all. And after this, chapter 10 should be a piece of cake. All right, so the last lesson is on interval of convergence. So we know how to find the radius of convergence and also the interval using the ratio test. So when you're looking for where the series converges, the easiest test is first to use the ratio test. And by using the ratio test, when the limit of the ratio of an plus 1 over an is less than 1, we have a open interval of convergence. So this tells us where, if any, where x will converge. But at the endpoints, we don't have any information. We just know that when on the open interval, the series converges absolutely because the absolute value converges. So if it converges on this open interval, we have to use a different test other than the ratio test, which is summarized in the flowchart and also in my handout, to figure out what happens at the endpoints. And that's the only thing that we're adding to what we've done so far, testing the endpoints. So for the exercises that I'm giving you today, you're applying the ratio test to find the open interval of convergence where the series converges absolutely. And then on the endpoints, at the lower end and the higher end, at both endpoints, you're going to have to do some other test to see what happens there. And then you will have the interval of convergence. So this is just another summary of what I just said. So here's example 6. Find the interval of convergence. There are 4 examples here. I'm going to walk through them very quickly. But you can pause and look through my work and look at the book for better clarification. All right, so here's a series. First, you do the ratio test, which tells us that the limit of the ratio, x squared, is less than 1, which gives us the convergence, the interval of convergence between -1 and 1, open interval. So we say the series converges absolutely on the open interval between -1 and 1. And the next step is to test the endpoints. What happens at -1 and 1? So if you plug in -1 where x should go, first x equals 1, then we have basically this is the series that you get, which is an alternating harmonic series times 1/2, which converges conditionally. And also, when you plug in x equals -1, you basically get the same series, different looking, but it's alternating harmonic series, which also converges conditionally. So you say, in this case, it converges absolutely on open interval -1 and 1, and converges conditionally on at -1 and 1.